Alright, so now switching back to our mid-grade tower, we are getting about 10% dropped frames. And YouTube went ahead and sent us a notification saying that we're live, so that was actually a lot quicker after switching out the computers. Yep, looks like it. Awesome. Hey, we're back. Haven't been on in almost 2 months, mostly because my main streaming rig went down. Looks like I either have a failing processor or my Zambezi failing power supply, or my Zambezi processor that I bought about 10 years ago is finally on its way out, but my, I think it's a AMD 8320 is performing at probably a quarter of what it's normally supposed to operate at. So because of that, haven't been able to do any streaming videos in a while. Went ahead and downgraded back to our old Intel Core 2 Duo processor streaming rig here, and we are actually getting some solid connection here. So let's go ahead and jump straight into it. It's been a little while since we've done something, but I got myself an interesting one here. It's a 16-inch A2141 that is just not turning on. Went ahead and I've already taken the logic board out, and what we get when we hook it up to our amp meter is about 20 volts and 0 amps, just so that we can replicate. Let's go ahead and turn it on real fast. So we're getting about 20 with 0.20 amps, 0.3, and then it turns itself off. So to me, that usually means that something is trying to turn on, but it never actually makes its way to complete all the power aliases needed for it to turn on. In the past, we've seen this be a shorted PP3V3S4 line, as well as a corrupted T2 chip. So in this case, I'm just going to go ahead and look at the power aliases and see if all of our rails are there. So let's go ahead and switch over to our board view and see what we got. So here we got our Flex board view by Paul Daniels, and what we want to look for specifically is going to be our power aliases. And this isn't the exact one we want to look for. We want to keep going through this page until we find these LDOs are necessary for turning on our CD3215s, but we're not really concerned about that right now. Because we do have power. This schematic looks a little bit different than what I'm used to working with. USB-CX support. This one is going to be LCD backlight driver, which we're not concerned about. And this one is USB-C-T support. So this is a little bit different than what we're normally used to. I see a lot of LDOs, and these are going to be what does that stand for? Limit dropout, I think. This is going to be what ends up creating our 20 volts on our CD3215. So this doesn't look like the normal power aliases of what we've seen in previous schematics. So let's take a look at the first page. Let's go back to page 1 of, and just kind of read through the table of contents. See what we have here. In fact, actually, one second. Let me pull this up just in case. There he is. Hey, how's it going, Tim? I actually had to pull a different computer out from the grave, essentially, in order to get this one working again. Okay, so let's see what we're looking for here. We want to look for something to do with power. Typically, it's power aliases. Power sensors, thermal sensors, PP bus power supply, battery charger, PMIC, LDOs. It's been a little minute since I've done an A2141, so I can't remember. Here we are. There's 2 separate power aliases pages, one on page 117 and 118. So let's go ahead and just look for 117 of. And that takes us back to USB-C-T support. So maybe this actually is going to be low dropout regulator for DC linear voltage regulator that can regulate the output voltage even when the supply voltage is very close to output voltage. that was a mouthful. Page 118, GPU 3.3 volt, GPU discharge. That's not exactly what the index had told us. There we are. It was sheet 117, not power alias. I'm sorry. It was sheet 117, not page 117. Sorry, it's been kind of a long day. All right, so first thing we want to check and see is, do we even have our PP bus present? We should have our PP3B3 present because that's how we have our 20 volts coming from our CD3215s. I think this one has CD3215s. I don't think they switched them into CD3217s on this model yet. I was wrong. This one does have CD3217s. Alright, so let's take a look over here at these fuses at our PP bus. Alright, so it's going to be about right here, specifically, are our fuses for our PP bus. And measuring with our multimeter, we are getting 12.61. That sounds about right for this unit. Oh yeah, I'll keep the multimeter down here. I did buy a new multimeter from Banggood, probably about 2 months, that is supposed to have a USB interface. And because of the crazy snowstorm that happened in Memphis and Texas, everything's just kind of been a little slowed down right now. So it has not arrived yet. So we're working with what we got. All right. Let's look at make sure I'm not missing anything. All this looks like this might be related to PP bus since it's in the name, but this one specifically is also talking about our real-time clock. Actually not too familiar with that line specifically, so let's take a look. It's still the same voltage as PP bus, but let's see what's going on here. So it looks like it's going to be down here on the top side of the board, same side as the CPU. And what kind of voltage do we have on U? Okay. Yep, still PP bus. So that's just a PP bus line. Let's continue looking forward on our schematics here. This is going to be CPU. I'm going to take a guess that this isn't present, only because we're not drawing enough amperage. And it's actually in a very inopportune location. But let's see if we can take a look at it underneath our microscope camera. So we have a couple of capacitors right here. And these two right here in the middle are supposed to be your CPU V-core. And CPU V-core is not present. Okay, so somewhere in between PP bus and CPU V-core, something's not turning on. Let's now look for our, whoops, let's put this back up. Let's now take a look at our 5 volts and our 3 volts. Let's see, this is 1.2. I'm not really interested in this stuff at this moment. So this is probably going to be on the next sheet. Power alias is 2. Here we are. So we have our 3v3s and our 5. So let's take a look at our 5GS, our PP5VG3S. I don't know why I couldn't say that. That is in a lot of different spots on our board. Let's kind of look back in the same area we were earlier. So this right here is supposed to be our 5-volt line. We are getting some pulsing. Let me just make sure that I actually have a stable connection here with my ground on my multimeter. we have 5 volts and staying at 5 volts. So my left hand was just shaking a little bit too much to where it was kind of jumping all over the place. That's perfectly fine. And what I want to look for is the equivalent of 5VS4, but I don't really see anything like that here. And we know that we have our PP3V3 and G3 hotline present because that is how we are turning on our CD3215s. We can just confirm that real fast by probing this resistor right next to our battery connector. It's kind of tucked all the way over here, but I think we can reach that. Yep, 3.3 volts, which would make sense because 3.3 volts is necessary. Oh, what is this? YouTube is not receiving. What is this error message I'm getting? YouTube is not receiving enough video to maintain a smooth stream. As such, viewers will experience buffering. Let's see what's going on. Our network has also been pretty choppy here too. Let's see. Looks like we're going to have to change something with our bitrate here. Hold on just for 1 second. I will be right back. What is going on? Okay, after changing our bitrate, now we're only dropping about 5 frames per second. Let's work with that for the time being. Back to what we were working on. Okay, so we know that our PP3V3 G3 hot is present. So these look like these are all G3 hot or G3S. I don't know if that is G3 sleep, standby. I'm not sure what the S stands for in this regards. So is there any other power aliases that I might be overlooking here? Let's see what's on our next page. Next page is signal aliases. This isn't going to be anything we're looking for at this particular moment. Let's just check searching directly on the board view itself. So PP5V underscore S. Yeah, see, there's an S4 right here, but that's going to be going strictly to the USB-C. So something looks a little bit different than what I'm familiar with. I apologize if I'm not as knowledgeable, as some other videos don't really work on enough of these 16 inches. So let's kind of take a look over here, see what's going on with our USB-C. Our PP5ES4T USB-C, that is on the top side of the board. It's these giant capacitors. We don't even need to put this underneath the microscope to take a look at them. Let's see what we have here. And we have absolutely nothing. No short to ground. Let's see if we get a pulse when we first plug in our USB-C ammeter. Because it does try to pull 0.3 amps before it shut itself off. Okay, so it doesn't look like that signal. That signal, I wonder, because that is connected to our USB-C, if that's because we are actually hooked up to this specific side of the logic board. Because whenever we did a search, I'm just kind of talking out loud here, when we put in pp5v underscore s4, we can see that there is a T and an X. So what happens when we look at our X USB-C? That is on the other side of the board. Is that potentially where we have some power? Right now I'm just kind of going off of experience with previous power aliases, just to see if there is any obvious power or missing power. So we have C3506 right next to our CD3217s. Let us go back to our microscope camera. And our multimeter says 0. And just plugging this in real quick, since it is pulsing at first. Okay, this is the part where I wish I had 3 hands. What is your meter reading? The meter reading right now says 0. However, when I first plug in my multimeter, it actually got a reading. It almost looks like it spiked some power there for a second, and then is dropping. Let's try that again. No, nothing there. Still 0. Okay. This is one of those repairs where we actually have to think. That's why I wanted to do this specific stream. USB-C, that is. Oh, the USB-C ammeter, if it is reading 20 volts at 0.2 amps for probably about 5 seconds, then it goes to 0 amps. Now, from my previous repairs, whenever I had that, it usually meant there was a short somewhere on a main power rail. Now, I know since this one is a T2 chip, this one can also have a corrupted T2 chip and going into DFU mode as well. Let's keep moving. Is the battery any good? Oh, it's a 16-inch, as in it needs the right charger. Hold on. That is a very good question, Kevin. 1 second. Let me see if we're even using the right charger, because this one does need a battery. It is a 96 watt. Yep. Aha. So that is the right charger for this one. This one can turn on without a battery, though, as long as it has a 96 watt. Good to see you live again, sir. Good to see you too, iPro Repair. I just haven't really had a working computer lately to be able to do this. So that is a good theory. We don't have any replacement batteries here for a 16-inch. Last time we got one, we actually had to end up getting a used top case, which was roughly around, I want to say $400. It was not really the cheapest right now, and there's a lot of really bad aftermarket batteries out there. So we're kind of avoiding getting any batteries for the 16 inches. But this battery, unable to really test out at this moment until we can get it to turn on. The 96 watt charger is enough for this to still turn on without a battery. So let's carry on onward. Yeah, let's see, what are we missing here? So, like previous devices, we had different power aliases all on one page. This is a power alias as well. This is supposed to be a 3.3 volt line for PP5ES4T USB-C. And no, I'm sorry, I misread this. This is a 5-volt line right here, PP3V3SO. Switch TBT TSN 3.3 volts is supposed to be 3.3 volts. Okay. Let's just keep searching on our schematic for this specific one. Primary ACE USB-C port controller for UPC, and that plugs into PP cable. USB-C port controller TA. And it looks like this CD3215 is responsible for eventually making this PP5V S4 line. Interesting. Okay, so we have a logic gate right here for UPC T5V enable R. And so we get PP5 underscore, or PP5E underscore G3S goes into UB700, which from my experience is not a CD3215. I'm sorry. What is this? It's on the back side of the device. And it looks like this is responsible for eventually creating our S4 line. Let's take a look at UB700. So we're going to have to actually flip our board around. Is this one of the models that won't act without a BMU cable? BMU. I'm not sure what that is. Is that going to be the battery cable? I'm actually going to have to do a quick Google search on that one, Tim. I'm showing my ignorance here. Yeah, battery management unit flex cable. Interesting. Okay, so that's going to be the data line cable then for the battery. This one I've been able to turn on without that cable present. I had one very specific one I can think of where we were able to let the client use the computer while it was connected, plugged into a charger, while having that cable removed, because that cable was actually the issue here. With that specific client. So he was able to continue using the computer without the cable plugged in as long as he had the 96 watt USB-C cable plugged in. So this is UB700. This little guy right here that says gas serial. So what we want to look for here is just verify that PP5V underscore G3S is going to pin 19, and if we actually have an enable line coming from our UPC TVR enable. Where is pin 19? That is bottom right, and pin 15, which is our enable, is the fourth from the left on the bottom side. Turn on our multimeter and make sure that our USB-C is actually plugged in. So pin 19 is going to be 5 volts. That is present. Now we want to check and see if our enable signal is present. It is not present. Okay, let's go a little bit further up the line. Actually, when a rail is not present, just for safe measure, I like to make sure there's no obvious short to ground, and there's not. All right, so let's go back to our schematic here and see what's going on. So UPC TV enable R, there is a logic gate right here, which is UB740. That is on the bottom side of the board. To the naked eye, it looks perfectly fine. And in order for power, it looks like it's going to be a 3.3 volt line coming from our PP3B3G3H_T. We're going to have PM RSM reset L and UPC T5V enable present. All right, so where is this? To the naked eye, looks perfectly fine. With the microscope, looks even better. Okay, pin 6. That is bottom right. And pin 3 is top left. And what do we have? Nothing coming there, which may be okay because PM RSM reset L is a low line, but nothing at all coming from UPC TV enable from pin 3. All right, we're going to learn today. Where does this line come from? Okay, this is going into U1200, which is our, hold on, it's a little bit of everything. Platform Controller Hub, Real-Time Clock, ESPI, and PM, Power Management. I don't believe that's the T2 chip. No. U3900 should be the T2 chip. Okay, well that's it going into something. This is going into something, but where is it coming out from? Probably directly from the CPU. And this is probably just a rabbit hole at this point. It is coming out of PCH PM level shifting. Okay, U4760. Does U47... hold on. So the signal has to be low in order for... Okay, hold on. Let me look at our logic here. The signal here has to be low, which I would imagine 0 is low enough, as well as this enable line has to be present. And we have a resistor. This is a confusing logic gate because usually a logic gate will not send power to the output until these lines are present. This line will not be present, from my understanding, until sorry. Sorry. Let's see, where else does this come from? Aha, okay. So that is going to be coming out of our digital core I/O and controller, which is UB300. UB300 is our, looks like a USB-C port controller TA. Is this the equivalent of a Thunderbolt port, or is it just a CD3217? That's kind of what this looks like here. So UPC T5V enable. That line was not present. That line is generated from, CD3217. Is it possible here our CD3217s are only partially turning on? Yep, here's it coming out of UB400. No, we don't want to search UB300. We know where that's at. We want to search for UPC TV enable. Sorry, right now I'm actually measuring the resistance to ground on our UPC-T5e enable. And it looked like it was 100 kilo ohm, which sounds normal. That's too specific of a reading for that to be something off. All right, let's switch back over to our, I still have my microscope camera pulled up. So if you are not turning on all the way, how is it that you're getting 20 volts but still not sending an enable signal? We may actually have to check to see if all of our LDOs are present. I am going to go to logi.wiki real quick just to do a little bit of research. So let's check and see if there's any information about CD3217. Power on sequence for T2 and CD3217. Awesome. If CD3217 does not have the LDO outputs, test the lines for shorts. Okay, bad CD3217 can often cause a loop at step 10. Needs to be fully functioned, communicate with the system management controller before the CD3215 connected to the charger will request 20 volts. We are getting 20 volts though. These documents are for specific boards, but will likely apply to most T2 Macs. Okay. There are a lot of steps here, but that is the power on sequence. Specifically, they said step 10. Now let's see what we have here. Okay. So we actually need to have a PP1V8 sleep S2R present before. Hold on, maybe I'm reading this wrong. PP3VG3 hot. And then this is turning on our SSD. PP3V3S5. And what is this specific sequence? This isn't for our specific board. Okay. What is it that we are looking at here? It's not properly loading, so this doesn't look like it's helping. It is thinking about it though. There we are. Okay, so this is the normal power on sequence. PP2V, USB-C. See, I didn't see this type of power rail there on this specific computer. So this one's probably not going to apply to our 16-inch that we have here. Eventually makes its way to U7000, which creates our PP bus. And eventually turns on the SSD. Cool. Did you change the USB-C board? I'm actually using one that we usually use for board repair. But what I want to check out is I have only been using one port. So if there is an issue with our CD3217, I am going to go ahead and just try a couple of different ports here and see if we get a different reading. Alright, so we're getting 20 volts here, 0.2, and 0.5. 0.05, I should say. And now it's just pulsating. I think that was the same thing that we were getting on this bottom port here. volts, 0.3, and immediately dies to 0.05. Alright, let's take a look at the other USB-C port right here. Volts is 0.0, 20 volts is 0.3, and then 0.05. So it looks like I'm going to get the same reading across the board. Zero point 0, 0.2, 0.0. And that one's only getting up to 0.2, while I think the rest of these were doing about 0.3. Okay. Let's give this one a visual inspection. How about that? And let's see behind this specific tape that we have here. Alright, so this is going to be the actual Thunderbolt IC. And everything looks fine here. Just the top right here looked a little suspicious, like someone else had messed with it. So far, I don't see any obvious signs of damage. Okay. I'd say with the visual inspection, nothing too obvious on here. So where do we go from here at this point? We do know that we are missing that UPC line. What specific was it? The UPC-T 5-volt enable line, and we did determine that that line was coming from our CD3217. So if we're missing that specific line, I see video starting to get a little bit choppy on my end. If we're missing that specific signal, let's go back to our CD3217. So yeah, whenever we were measuring, we were at about 100 kiloohms to ground. That's because we have this RB 2320, or I'm sorry, 232. That is a 100 kiloohm resistor, so that's the right reading. So this is going to come out of our CD3217, specifically the SPI ACE digital core I/O control. So this needs to turn on first. The actual IC IC needs to turn on first. So what's strange is that it's already getting 20 volts. So oh man, this is where things get confusing because we need that enable line present before we even get power needed to create our PP5EO PP cable. So it looks like this talks to a couple different things back and forth until it eventually turns back on. Thunderbolt T CI power enable, CIO. This is an input. This is Thunderbolt T USB power enable going into it. UPC power management unit reset. Out of curiosity, let's check this LDO right here. PB3V3 UPC TALDO. That is going to be part of bus power. And that is on the bottom side of our board. Let's turn our multimeter back on. And this LDO, we are getting 3.3, so that is necessary. That is in fact present. So we got our PPV bus USB-C TA. That's going to be what powers on our V-bus right here. That should be present though. And there's that PP1V8 sleeper, or sleep S2R that we were talking about earlier. That's in a spot that I don't necessarily want to probe. Okay, there we go. So that seems to be present. PPV bus USB-C TA. Or I'm sorry, not present. The opposite. I'm sorry, like I said, it's been a very long couple of weeks. Okay, no obvious short to ground. So, where does PPV bus USB-C TA come from? It's probably going to come out of CD3217 later on down the road. Okay, so that is supposed to be a 20-volt line. But what creates you? We know that you go into the CD3217, but where do you come out of? And it looks like... hold on. VBus OPT. Opt. Optimization? Not sure what that stands for, but... Let's see where else. Ah, okay. USB-C-T connector. Looks like it is talking on pin 60 of whatever JB500 is. PPV bus USB-C TA. PPV bus USB-TB. Now, on previous USB-C models I've worked on, the TA and the TB are actually going to be different ports. Is that what's going on here? What is JB500? Let's just kind of explore this rabbit hole. JB500 is going to be the actual connection where our USB-C port plugs into. So that's exactly what it looks like here. So we might be missing our PPV bus USB-C A because we were plugged into a different port. Let's simply change that. I am so sorry. That should not be that loud. I apologize to headphone users. Alright, so we plugged into a different port. I'm going to have to get some WD-40 during this stream. Right, now that we are plugged into a different port, let's see what we get as far as that VBus line goes again. Yep, that's exactly what was going on. TA is going to stand for this specific USB-C or CD3217, and the USB-TB is going to be this specific one. So we're getting 20 volts here like normal. That's perfectly fine. Red herring. Now that we know that, let's revisit where that is specifically on our UB300. UB300 is this specific CD3217. Alright, and so we were looking for VBus. So VBus is just going to be essentially the power for this specific part of it. And we're going to have voltage in 3.3 volts, LDO 3.3. So we probably should make sure that these lines are present too, just to make sure it's getting the proper power. So let's do just that. Let's look at VN, which is going to be PP3V3, G3 hot, real time, clock X. I think we checked this one before. All the numbers are kind of matching or are blurring together at this point. Yeah, we did measure that earlier. So we do have 3.3 volts, so that's perfectly normal. And let's check our VDD I/O, the PP1V8 Sleep S2R. It's going to be CB302 on the bottom of our UB300 1.8, and that is present. VDD config. I'm not sure this is anything in particular we're looking for. If anything, I would imagine this is a signal to change the different VDD voltage. And it doesn't necessarily show me anywhere directly on the board view where it's coming from. I might regret this later, but I'm just going to skip that line, and let's go to PP3V3 UPCT ALDO. We've actually have already measured that line before, and it does have 3.3 volts, so we're just going to skip that. And PP3V3 TBT TSX. .003. Schematic says that specifically is V out LV. We have V in LV, but we don't have V out LV. Just going to read the resistance to ground on this real fast. .34 kilo ohm. Yeah, 34 kilo ohm. That sounds normal, but I'm curious as to why that's even missing in the first place. We know that VRET is going to be present because that's part of our PP3V3G3 Hot RTCX SS Super Saiyan for you Dragon Ball Z fans. Not sure what that is. I'm going in this completely new, open-minded. And I've done a couple of these, but this one just definitely seems a little different. What is our Super Saiyan line? It's nothing. SS is nothing. Looks like it's just connected directly to ground. Let's check our LDO core, the PP1V5 UPCT A LDO core. It's going to be CB304. CB304 is this specific capacitor, and we do have 1.5. All right. And VBus opt. I feel like this is going to be present. I'm not sure if this is in direct correlation to PPV bus USB-C TA. Yeah, no, that's already present, so we actually don't need to check that. We're going to go ahead and skip that part. PPDCN TAG3 Hot F. Not sure what the F stands for in this regards. F for free me. Feedback. That's what F's got to stand for. All right. Only reason I say that is because on the actual board view it says FB200. I don't know if that's a feedback line. Whenever we measured PPDC and TAG3F, we are getting 20 volts. So that seems about right. Okay, so this part of the power area seems okay except for V out LV. Is this something that we should consider looking into? Why not? I feel like we're going to be on this room for a while. So let's go ahead and check our schematic and see where this goes to. And it looks like it is 3.3 volt SO switch, Thunderbolt T switch. So it takes PB3V3G3T. Wish I knew what the T stood for. And it's going to be CMP computer. These are new abbreviations I'm not too familiar with. eventually it's going to make our PP3v3 SO switch TBTT, which comes from our Thunderbolt power enable, which is what turns this on. I might be getting a little ahead of myself here. Did we already measure this line before? The PP3v3 G3 hot T. We did. That line is present. What about Thunderbolt power enable? I might be getting ahead of myself here. This is probably something that eventually turns on, but not what we're looking for at this moment. No, I'm not getting anything there from Thunderbolt power enable. If I had to guess, this is going to be coming from our CD3217 and is going to act as a voltage divider. I'm going to assume the CMP is going to be some sort of switch based off different voltages. It's going to be doing different things. This is all just a guess. The only reason I say that is because between our PP3v3 G3 hot T, we have one resistor right here and another resistor. Now the voltage in between, which is PP3v3 TBT T CMP, will change if this turns into ground. Now this is not ground, but I think the CD3217, when it turns on, is actually supposed to ground this out, which drops the voltage on our CMP from PP3v3 TBT T CMP. So that's probably normal, what we have going on here. We're not getting any voltage, and when it's turned off, we're not shorted to ground, probably because the CD3217 has to actually be on. So let's skip this part. This is just a red herring. Let's keep going. And this is where it starts getting a little bit complicated, because that eventually makes its way to TBT RTD3 power enable, which is part of our POC GPIO. Okay, we are definitely going down a rabbit hole here. Another thing I could do, I could cheat. Only because I've spent a good bit of time here. Cheating would be, you know, let's cross our fingers there's a short somewhere. Like on our, if whatever the equivalent of our 5ES4 and 3V3S4 lines are on this specific computer, if there is a short, we would be able to detect it using our thermal camera. So we're going to please bro here for a moment, only to see if we can kind of speed up some time. We gave it a visual inspection, and it's perfectly clear. So let's see if there is something that is shorted. Let's open up our software. Things are probably going to get a little choppy here, because this is a little processing intensive, more than what this Intel Core 2 Duo computer can handle. I'm actually struggling just kind of moving this over. Yep, and just like that, we are dropping frames. So please deal with me for a moment while we kind of resume what's going on here. And it's just going to be very miserable for a moment. It looks like it's going to update about every 7 seconds. Let's let's see. So we need to change this to on screen. Okay. I'm so ready to have my streaming computer back. Alright, nothing on that side of the board, and that was pretty miserable to watch. Okay, so that's going to be your T2 chip right there. And nothing obvious. Okay, so at this point, I'm curious if this may be going into DFU mode. Let's go ahead and get rid of our thermal imager program, because I'm curious if UB300, in order for it to actually send that signal through UPC, what was it? I already forgot the name of it. It's the 5 volt enable line. I'm curious right here for the digital core I/O and control, in order for it to actually send the UPC T5 volt enable line to actually create our PP5ES4 T USB-C, does it have to talk to our T2 chip? All right. This one just keeps getting more and more interesting. So what I'm going to do is just briefly reinstall the logic board back into the top case, and I'm going to hook it up to one of our controllers, that's our computers, that is running Apple Configurator 2. And then we can see if this computer is putting itself into device firmware upgrade mode. You mentioned the BMU missing, Tim, and it's not here. Hold on. Let me see if one of my techs had removed this. that cable is indeed missing. Okay, the only reason I'm confused here is from my previous experience, we actually had a client where his computer just had a really bad battery. So the fact that he was able to continue to use the computer with the BMU cable missing and the battery not even being plugged in led me to believe that maybe this one could survive without having that specific cable plugged in. Because that was a case we did probably about 2 months ago at this point. If so, I actually don't have a replacement BMU cable in stock for this specific model at this moment. At least I don't think so. I'll have to double check to see. Still going to end up hooking up to another computer running Apple Configurator 2 just to see what exactly, to see if this is putting itself into DFU mode. Okay, do we have all the cables out of the way? Looks like it. Cables never seem to want to go into their home while I'm doing a stream. It would be silly if that's all it was this entire time. Now, when this one was brought to us, it was already partially taken apart. So that should have been a red herring that probably should have looked around to see if there was anything someone had forgot. But the main reason it was taken apart is because it didn't turn on. So in these cases, it's a little hard to troubleshoot what is the actual issue and what is the client caused issue. I think you can recall I had a video or stream probably about 2-3 months ago. I did 3 streams on it, and I finally fixed it. Actually, the last time I fixed it, I ended up recording it rather than doing a stream because I kept getting interrupted in the middle of the day. I just didn't want it to didn't want to have a stream of nothingness for a while there. Where was I going with that? Oh, but the situation was that I ended up repairing the original issue, but then I spent forever fixing the custom-based issue. I don't think I have an A2141 in the shop right now. I have an A1990, 3 A1707s, A1708, and A2179. Awesome. Sounds like you got your work cut out for you. That's good. Good job. I will be right back. I just need to grab another computer here. One that has our Apple Configurator 2. And where did we put that computer? Here it is. Of course it would be dead right now. Not a problem. We have chargers. Alright, so we have to plug our cable from the master port, which is going to be, I believe, the closest port to us, on the left side of the computer. And then we're going to plug it into any port on another USB-C MacBook that is running Apple Configurator 2. Alright, 20 volts, 0 amps. Alright, so now we have this computer turned on. Let's open up Apple Configurator. The trackpad is getting power because I can feel it move. Hey, looking at the schematic, I see the battery is one of the SMC4G3 hot connections. No. That very well could be the issue that we're having here then, Tim. Because if that is connected to the SMC line, then that could also be why the computer's not properly turning on. So this may be a disappointing stream. I might not be able to actually fix this one with that missing BMU cable. So now the question is, do we have one that we can use? We are not going into DFU mode over here on our USB-C computer. Let's find out what we have in the system. If this doesn't work, then I'm just going to go ahead and jump on a MacBook Air that came in earlier today. Get something juicy for the stream. Okay. Nope, does not look like we have any of those in stock. Alright, let's see if we can get one. Dang, I wish I had a 2141 in front of me. I've been lucky with a couple of the ones that we've worked in the past. Usually it's been like an obvious short or liquid damage and we just replace the individual components. But for it just simply not turning on, it looks like we have to address the client issue first. Okay, we can get the ports, or the parts. We have to address the client issue first before we can actually do the main issue, main repair. Okay. So if that is the case, thanks to Optimized Logic Repair, here he was able to pinpoint that the battery connection looks like it is also connected to an SMC4G3. Oh, it's connected to 4 G3 hot connections. Hold on. Let me pull this up myself real quick so I can take a look and see what you see. Are you looking at the actual J6950 or J6951? Client issue. What I meant by client issue was that the fact it is missing the BMU cable. That showed up completely removed now that I'm thinking about it, and the bottom case was removed. So we're at a point to where sheet 52, thanks. I'll take a look at it here in a second. We're in a situation here to where we need to figure out what issue has the client caused. In this case, it looks like because the BMU cable is missing, we might not be able to actually progress further to see what is preventing the rest of the computer from turning on. Let's take a look at sheet 52. Thank you for taking your time in helping me. Sheet 52 of 135. Okay, let's see what we're looking at here. Oh, whoops. Yep. That's kind of what's going on here. Okay, let's see what we have here. Our system on chip, left speaker, audio codec, ALS, which is for the camera, DFR. This is going to be all for touch bar. Awake connections. Also for the camera. FaceTime. Okay, if you're referring to this right here, let's take a look at U6950. Okay. The battery actually does have an ITC line, power clock data. Because we do have our PP1V8 SLPS2R, so it is going to be talking to our system management controller, Calpe, and battery charger. Shouldn't the device still turn on even if the battery's not connected? Does this have to be present? Because this is just going to be a data line that going back and forth to the battery. I don't know if this necessarily has to be present. I might be wrong in that regards. You said try looking at sysdetect L. Okay, let's do just that. Sys underscore detect underscore L. That's going to be coming from J6951. Yes, this is the BMU cable that you were referring to, which eventually makes its way past this transistor to PP3V3G3 hot RTCX, which we did verify is present. This is what I'm thinking. Sorry, wrong connector. My bad. Alright, well I actually have my board upside down right now, so let's kind of flip the board view around to match what we're looking at. Being that our BMU is not connected, I'm pretty sure we shouldn't get anything. That also has the two I2C lines. Yeah, so it is low, which I feel was to be expected since the battery itself is not actually plugged in, nor is the BMU. Same has battery, no. The battery does have two I2C lines, you're absolutely right. Okay, I'm just making sure there wasn't anything that was pulling that down, and it's not. So why I just keep thinking maybe this is a red herring is only because whenever we ran into this issue before, I know for a fact we didn't have the BMU connected nor the battery, and it was still able to turn on as long as we had a 96 watt connector here. But I don't know if it could go into DFU mode if that specific cable is missing. So we're going to stop right here. I'm going to do a little bit more research. I'm going to end up ordering a replacement cable at this moment. Actually, we'll just go ahead and we'll kind of get a few of them just in case. And let's work on a MacBook Air. Get something that actually is going to work, or something that we can actually fix. How about that? Before I forget, let's go ahead and add this to our cart. Let's get a few of those. Why not? Not today, buddy. I'm sorry. We will fix you some other time. I'm gonna get some too. Makes sense. All right. Let's see what else came in today and what bin it's in. All right, so we got ourselves a MacBook Air. Looks like 2013, 2014. That is in for just not turning on. I actually have recently got a digital power supply since my last couple of streams. So let's see if we can get that hooked up here working with our OBS. Cool. Okay, so it looks like it has popped up. And let's see, it looks like since it is digital, we actually have to change everything on the computer. I can't set it using the actual power supply directly. So we're going to change our voltage here to 18.5 and our current about 4. And let's hit our start button. And see if this actually works. Alright, just doing a little bit of troubleshooting real quick, just to see if we can actually get our power supply working here. Not today. Okay, well, we tried. Okay, we'll just go ahead and get rid of that. A new power supply unit. What did you get? I ended up getting a power supply from Circuit Specialist. It's actually very similar to the one that I used to have, except this one does have a USB connection that doesn't want to work right now. So we're just going to ignore that for the time being and just continue with the board repair like normal. So this MacBook is in here because it was just not turning on. A second ago, I actually just saw a fan spin. So let's see what happens when we hook it up to our power supply. So we are drawing about 0.6 amps right now, and we are getting a fan spin. And this is a 3474, I believe, which means the computer is going to boot loop a couple of times before it actually turns on. So screen just went dark, and Apple logo. Why is this one here? I can't win tonight. I want to do a board repair. Yeah, this one just booted up just fine. We have a charger, we have a fan spin, and we have a wallpaper. So, I'm not sure why this one is in here. This one was quoted by the actual Apple Store to have had an issue. But it's turning on just fine. Let's pull the logic board out, just to make sure that there's no obvious signs of corrosion. Because why would the Apple Store deem a perfectly good MacBook to have a logic board issue? Why would we have taken this one in and deemed it a logic board issue if it turned on just fine? I know we would have been smart enough to actually hook it up front and test out some general diagnostics just to see why it wasn't turning on in the first place. And who took my screwdriver sets? Missing camera? Which camera? The computer camera or my camera? Do want to get a better camera though, speaking of cameras. These Logitech cameras, they get the job done, but they're a little grainy. They claim to be 1080p. I actually have to scale them down to 720 with this specific computer. It just can't handle 1080p stream. I can hardly handle a 720p stream. Missing camera on the MacBook. Oh, eyesight cable's right here. Camera is present. And we live in a world nowadays where cameras are very important. Or no Wi-Fi. Wi-Fi's right here. We got all our cables. Are you being a bipolar computer? You want to work sometimes and other times you don't? I've got an A1708 at 5 volts and 3 milliamps, worn out USB-C ports. Anything at 30 milliamps. Is it 30 or 300 milliamps? Because it sounds to me that maybe just the USB-C port is, like you said, worn out. That'd be a nice one. We all need a win sometimes. There are some repairs that take way too long. So replacing the CD3215 and the soldered USB-C port should be fun. Oh, A1708. Sorry, it just dawned on me. Yeah, that one is not modular. Aha! Found it. Now we know why this one's in here. Oh. liquid damage around the Thunderbolt mux. So what probably happened here is the computer wasn't turning on at Apple, and when it was checked in here, it wasn't turning on at all either. And by some weird fluke, it turned on when we hooked it up to our power supply. There we are. Our CD3211 Thunderbolt port power mux. So let's just replace this after we look around and make sure there's no other signs of damage. What is that? Only thing is, you both know that A1708 has solder on ports. A1706 has screw on ports. Exactly. Maybe it dried out. LOL, fungus alert. Yeah. This is why we wear gloves. We wore gloves way before there was a pandemic. Looks like a piece of Himalayan sea salt. Good to see you, Pedro. Haven't seen you in a while. I think that is a very good idea, Tim. Alright, everything else looks good. Let's just work on cleaning this up. Finally, turn on my fume extractor tonight. Fungus is a really good word here. Well, whatever this is, whether it was a resistor or a capacitor, it is gone. Before I hit this though with some flux and kind of calcify the remainder green fungus, we'll call it in this case, I'm just going to kind of swab this down with some 99% isopropyl alcohol. Looks like a seahorse pooed. Yes, Pedro, definitely watch some of Tim's videos. He's smarter than me. Alright, so we're just going to replace the CD3211 as well as these three. They look like capacitors. So before we actually start heating this area up with our rework, I'm going to hit it with some low melt solder by using just our micro knife. Now that we've touched that up, let's go ahead and get our quick rework station and just start heating up the area. So there goes that capacitor. Waiting for all of this to kind of heat up. This one's definitely going to get a bath, because if it has corrosion like this hiding underneath the board, I want to make sure there's no corrosion hiding underneath our backlight driver. Okay, so before we could just start swapping over components, you can kind of see right here, the traces are not really exposed as much. So we're going to have to etch into our board with our surgical scalpel, just to kind of expose some of the copper, if the copper is remaining. Like if we look right here, this looks like maybe this was a via that is gone. Let's give it another swab with some alcohol here. Yeah, so this little component right here is the pads are completely melted away. So we need to figure out where it goes to. It looks like it is connected on this trace. So we may be able to just kind of run a wire between this capacitor and this component as well. Now, this pad looks to be non-existent as well. And it looks like it's supposed to connect this capacitor. Only reason I'm assuming it's a capacitor is this looks like this is all ground. And usually capacitors are commonly on ground. They could still be a resistor. Anyways, this capacitor is supposed to run right here to this part of our CD3211. So we're going to have to just kind of run a wire here. And I'm curious, should I do that now or after? I will probably do that afterwards. Yeah, I think that's what we're going to do. Okay. This normally happens when anyone ever spills anything through the keyboard. This is the part of the board that's actually exposed underneath the keyboard. Oh no, there's a via. I don't know if you can see that, but there is a via underneath hiding there. Yep. Alright. Schematic time. So this one is an 820-3437. It has been a little while since we've actually had to pull up a schematic for an 820-3437. So let's go ahead and search our computer for it. 820-3437. So our Thunderbolt 3.3 mux, or maybe it's just 3 volt mux, is going to be our U3210. It is a 3.3 volt mux. Alright, so this capacitor is going to be PP3B3RHV_S4_ Thunderbolt power. That is going to be coming all the way from this component. So we could do one or two things here. We could either try to etch into our via and make a solid connection, or we could just run a jumper wire directly from these components. The only question I have here is, where does that via... Yeah, okay. So it looks like the via is going to be going along the underside of the board where all the backlight circuit is for our screen. So we could just simply run a jumper wire from our L3200, C3200 directly to our C3211. Or we could etch into the via. I think what's going to be a little bit more reliable is if we run a jumper wire. And it's going to be longer, but I trust that versus trying to etch into this via here. Let's do that. On top of that, we were also concerned about C3285. Exactly what I assumed. It is connected directly to C3286. So we will be able to run a jumper wire directly from that as well. So this is going to be fun. Alright, let's switch back over to our microscope camera and decide at this point, do we want to go ahead and run our wire now? Or do we want to go ahead and replace our Thunderbolt Mux IC? I think what we're going to do is run the jumper wire first. Yeah. And I will run the wire from here, from our C3200, and just kind of solder it directly onto this last little bit of exposed trace. Cool. I actually got a more high-powered UV light from store.rossmann group recently, and it is made curing mask on jumper wires so much faster than what I've done in the past. However, since it is more powerful, I now have to use a special type of UV protective eyes. My vision's already not that good. It's not 2020, but I don't want to make it any worse. Alright, so let's connect our wire directly onto this pad. This pad specifically is pin 14. Alright. Just go to your channel and copy your URL. Yeah, that works too. I agree with him. All right. So let me go ahead and actually switch out my glasses. Are you on the Facebook Logic Repair group at all? I am. I don't really post on there that often. I'm more on the Rossmann Discord than actually on the Facebook group. I posted there probably about 3 weeks ago when I discovered that you can replace the Wi-Fi IC on an A1708, but you also have to replace the Wi-Fi ROM and the Bluetooth ROM. That's so far been the only thing I posted. I'm kind of a lurker in that regards. I know that Joseph Hughes, he's on there a lot, so is Tim. Tim posts a good bit. Other Tim Herman. Alright, don't look at the light. Paired, yes. The Wi-Fi ROM and Bluetooth ROM are paired or married to the actual Wi-Fi IC I discovered. TCRS is the man. Tim's very smart. He's a very, very smart individual, especially for how young he is. I have an employee who's 17 He's pretty smart as well. It's just amazing how much smarter kids are. Well, I shouldn't say kids. I should say how much smarter just people are in general when they have access to more knowledge. I make myself sound like an old man. Timmy. I'm sorry, guys. It's been a long week. That was uncalled for. We hired someone new this week. Pretty excited to bring them on board. So now we have 4 technicians working here. This will allow me to spend more time doing board repair, while they can kind of take care of the general diagnostics and SSD upgrades on iMacs. Beautiful. Okay. And let's try to bend it a little bit more right here. Alright, my hand's only shaking because I'm trying to squeeze this at the same time while trying to actually put it on our wire here. There we are. But yeah, this laser is definitely a game changer compared to what we had before. We kind of had more of like a detective light. So it's the kind that you'd use on a crime scene. It covered more of a larger surface, while this is definitely more acute, more accurate, or I guess you could say precisioned. Like the other light we have, you definitely don't want to take to a motel. And you're going to see some things that you don't want to see. But this type of light is really good for curing, just curing a lot of things. Wonder how it'd work with nail techs. Alright, so this is going to be our L3200 and our C3200, and just to make sure, we basically just want to be soldered. We probably actually just solder ourselves directly to this via here. Or not via, it's a test point. Let's take a look back at our screen and see. So right here, that is, yep, on this test point. So that's exactly what we're going to do. Let's go back, get our, what am I grabbing? Grabbing some flux. How about that? Kind of a dab of flux right here. And let's also grab our solderer so that we can tin the area up. And now we're just going to push our wire down into this pad. Beautiful. Another thing with these UV protective glasses, it's kind of like putting the world into nighttime mode, day shift mode. Night shift mode, not day shift. Because everything is orange. Completely filters UV and blue light. Just everything's orange. Kind of comfortable. Flex board view for the win. Good for you supporting Paul Daniels and fellow Aussie. Are you from Australia? That's pretty cool. Yeah, if it wasn't for both Piranov and Paul, we wouldn't be able to do our work as efficient. That I am very grateful. Alright, I don't need these glasses anymore, so let's switch back to my actual prescription glasses. Now that we have that wire there, I think we are ready to go ahead and replace our CD3211. Let me just kind of put a pad or a mount on here. That's cool. Piernov is amazing too. He is. He is smarter than I could ever hope to be. Alright, so we have this area prepped. Now let's go ahead and take some donor parts from another MacBook we have here. Let's search for a donor. So this one is a A2141 and I got plenty of 00165s. They basically use the same parts, but I like to just pull one from the exact same board. Perfect. Found one right here. This one just looks on the dusty side. So let's go ahead and run some solder along the pins to make it melt a little easier for us. Well, thank you, Pedro. I appreciate that. I don't really have too much to talk about, though. Not quite like a Let's Player. I can famously talk about, like, food or comedy. At least not this week. Like I said, we've had a very, very busy week. I'd like to stream more, but since my main streaming rig went down about 2 months ago, it's been a lot harder, and we've just been short-staffed, which is why we ended up having to hire another technician here. Very, very happy with her. And now that she is here, she can help out the other technicians, so we can get more local customers taken care of, so I can focus more on board repair and streams. Because I thoroughly enjoy doing it. Stock market advice. I don't know the first thing about stock market. When everything went down with GameStop and AMC, all my adult friends, we'll call them, just because they're probably better at handling that kind of stuff than I am. Love talking about, but I had no arguments. I just am very ill-informed. And it's just kind of the way that I grew up. I was always taught not to invest in stocks nor have a credit card. I'm now learning as an adult that that is not the way to live life anymore. Female tech, yes, actually, I have 3 female techs here. Technically, I actually have, outside of me, there's 5. Other than me, there is 4 technicians. If you include me, then it's 5. There is one tech who is a high schooler. He's the president of the robotics team, part of student council, and taking college classes. He's definitely something else. He is very smart. Then I have my wife, who's been working with me for 5 years. She is a very, very smart technician. My sister works here. She is an esthetician, so she just kind of naturally has attention to detail. Makes her a great technician, catches up on some small attention to detail things that most people wouldn't catch. And then we ended up just hiring another female who has 5 years of experience working at franchise repair shops as a manager. And I can tell that she loves, I can tell that she's already enjoying the mom and pop aspect more than the corporate franchise that she used to work for before. So it does not matter what gender you are as long as you have a brain, because that is all this job is deductive reasoning. South Carolina, that is correct. I am in upstate South Carolina, about a 20 to 40 minute drive away from North Carolina. Alright, so we got our U3211 on there. Let's go ahead and get our replacement capacitors. Alright, this time I'm going to end up using my micro tweezers, so let me go ahead and switch that out. Alright, so we're going to cheat with this capacitor because we're going to heat up the ground area with our rework station while heating it up also with our tweezers. It's going to allow us to pull it off the board a little faster. Okay. Tim, if you have yourself an office in your house, honestly, I think for starting up reasons, that is the smartest thing to do, especially with board repair. Because with a storefront, everyone is just going to assume that you do iPhone screen repair. You have to brand yourself very well, and if you're getting work in mail-in, I think you are doing a very good job and also keeping your overhead low during these times. There's nothing wrong with that. Alright, so we will go back and touch this up in a minute. Just kind of loosely letting that capacitor sit there, and then I'm just going to kind of heat it up with my reflow station. Yeah, that's what every one of my customer tells me. You're lucky you work from home. During these times, I think that's a very a very privileged thing. Privilege is probably the wrong word. That word is not what it means 10 years ago. It's just a nice luxury. Alright, now we just gotta grab this tiny little capacitor here. And after that, we're going to be able to just kind of toast our board up a little bit. Melt all the components onto ground. Alright, so everything's kind of in place. Now to make it look pretty. Now that our board is kind of hot from where we last probed it, or heated it up with a rework station, we should be able to kind of touch this up with some solder and our micro tweezers. Alright, now let's kind of heat up the area one more time just to make all of this smooth. Oh, no, no, no. Don't blow away, little capacitor. Okay. I think we can work with that. Now, last thing we have to do is just kind of run a little jumper wire from this end of the capacitor to this end. So for that, I'm going to switch back to my micro pencil. Okay. And just to make sure that's got a nice solid connection, because this isn't pretty, but it's going to work. We're going to put a little ball of solder right there. Cool. That should work. My videos are not structured. While I am flattered, I kind of just roll with the punches. I appreciate it. I tried making a lot of uploaded videos that I would actually edit using Final Cut, but what happened is it just took me too long to edit and then actually upload. When I go home, I have to take care of other things for the shop or update our website. Just haven't had really the luxury to do that as much, so streaming seems to be a little bit more efficient for me. Okay. And let's just kind of touch up this side of this capacitor one more time, just to make sure it's properly touching the wire we made. And it is. I think that's going to be good enough for everything that we need. So, let's kind of just put this loosely back together and check and see if we have a working Thunderbolt. So this one did not want to work on. This one is now a donor board for obvious reasons, but it looks like it saved this MacBook here. Let's put our donor board away. Thank you for helping us today. And where is the rest of our computer? What bin did we put this in? Alright, it's this one. We actually have a couple of MacBook Airs. I just had to figure out which one we were actually working on. Alright, so now we need our T5 screwdriver just to kind of loosely put everything back in. We're not going to fully install it because we do need to still give this one an ultrasonic cleaning afterwards. And let's see, it's 11:41. Stream's been going on for about 2 hours and 10 minutes. Well, that's because a good an hour and a half was probably dedicated to trying to troubleshoot that 16-inch. I might actually go ahead and take care of a backlight for another MacBook Air we have here. Just to kind of get some more progress. We're starting to pick up liquid damage season here. I have another MacBook that has a lot of components that need to be replaced. Turns on, just runs slow, every now and then shuts off. A lot of components around the SMC are not in the healthiest condition. So that's another one I got to work on. Okay, and what we're going to do, just so we don't actually see any client data, is we are going to boot into a test drive. That's just an external solid-state drive that has different operating systems on it. Very, very handy tool to have. I have not had an iPad Pro port job or iPad charge port in a month now. That's good. Unless you enjoy doing those, then I guess it would be bad. I actually have a couple here that we need to do. Yeah, I'm actually looking. We have a MacBook Air charge port over here, and recently I actually had two MacBook Pro, or iPad Pro 11 inches that both came in with the USB-C port just completely charred. Almost looked like maybe there was some moisture inside the cable they plugged into the charger and killed it. But it's just weird that it happened to two of the same devices, two different clients around the same time. Okay, so here we have our test drive, and we have different installations of Mac OS. Must not be iPad charge port season. It is keyboard replacement. Have you by chance had any success replacing the keyboard on a riveted, let's say, USB-C model? The rivets are a little different. So I have not had success. I've had success on the older Retina models. What is that brick? This is an external enclosure with a 2.5 gigabyte Crucial drive. This has different installations of macOS as well as installers. Nice website you have. Thank you. I've spent way too much time and neglected my wife on too many nights working on that site. Admittedly, I've not updated anything in probably 3 months. I do need to finish taking care of that, but I appreciate you noticing. Yes, like A1708 keyboards. Have you ever replaced the key on there? Because the rivets, they're weird. It's not just like a standard rivet that goes straight down. It's almost curved in the center, so it's very easy to rip off half of the rivet. Okay, so the computer is now turning on. That's exactly what we want, but what we want to do is now plug into our USB, or I'm sorry, not USB, our Thunderbolt port. I'm too used to saying USB on the Thunderbolt on the other ones. So what we're going to do is hook up to this television here, and I need a Thunderbolt or mini display port to HDMI adapter. Let's see if we fix this one. Alright, it's detecting HDMI 2, and let's rotate the camera here. Haha! Alright, so we have a fully working Thunderbolt port on our MacBook Air. So I'm going to go ahead and unplug that. So that was a successful repair. It looks like the computer just wasn't turning on, probably because the amount of crud that was on there. So we ended up replacing the CD3211 as well as running a jumper wire on a trace that was completely missing, which fixed the Thunderbolt issue as well as fixed the computer from not turning on. And now Thunderbolt is working, computer is turning on. Got to finish doing a QC. We'll give this one an ultrasonic cleaning probably in the morning because I want to work on another board. So that was a successful board repair. Let's go ahead and work on another one we have here. Tim says, yep, what I do is after popping out the whole rivet, I take a 9mm drill bit and drill holes out except for 1mm keyboard, like what you would do for an Air. Bit tedious, but it works. And you all will have to pardon me for All right. Apologize for that. It's just the wife checking in on me. Okay, so this one has a backlight issue. So I'm just going to replicate it, confirm that there is indeed a backlight issue. So let's switch over to our overhead camera. Okay. Things are kind of just hanging here, so that's why I'm being a little cautious. And let's give it some power. And we're pulling 0.03 amps. Interesting. Let's end up pulling the board out. See what is going on here. Hopefully I didn't just do anything by having the Wi-Fi antennas up against the SMC. Let's try this again with that being removed. Still at 0.03. And now we're no longer getting a green light. Oh, there's our green light, 0.03. Got our amber light, and still just kind of staying there. So, let me check the notes on this one real quick, just to see what is actually going on with this one. Okay, found lots of liquid. Backlight circuit has lots of liquid damage. Let's take a look at that. I'm sorry, I've actually missed everything in chat. This computer is pulling 0.3 amps. So I'm just kind of checking the notes real fast. Note said that there was actually a substantial amount of liquid damage around the backlight circuit, which I would agree. There is a good bit right there. Although that shouldn't have anything to do with the computer not taking any power. So I'm just checking to see, since it was liquid damaged, if there was any other signs of liquid damage on here. It looks like it's all just around that. Look on this side. Nothing too obvious over here. Okay. Sorry, not 300 milliamps. 0.33 milliamps. I know, 300 milliamps usually is scary. Usually in my experience that's a dead CPU. So what we're going to do is we're going to remove this junk and then just try to get another reading from there. Kind of attack the obvious. Now, 300 milliamps is usually a very depressing number I get. I try to avoid that number as much as possible, because every time It's a dead CPU. Alrighty. Let's go ahead and start removing. So this is Tim's group, or question mark. I'm not sure what that means, sorry. Plural. Or verb. I don't know. I'm in Tim's group, but not Martin or Dustin's. Do different technicians have different groups? I'm actually unaware of this. Yep, there's a lot of crap underneath there. Now let's go ahead and clean this up. So since this is a ball grid array, what I like to do is just take a little bit of wick and wick up all those solder pads using the rework station instead of an actual iron. I'd say that looks a lot better. So let's give the computer a second to cool down and kind of catch up on some things. Let's see. I actually need to move this window over to a different side because I can't really see any comments because my microscope is in the way. What's going on here? Okay. Stuff I don't really want to poke. Okay. This has had some time to cool down. Let's check and see if now we get any change in our amperage consumption. You have a celebrity in your stream. I do? I actually have not been paying attention to chat recently. So, if you're in there, hello. Alright, still pulling 0.03. So, what are we missing here? Let's go ahead and start with our power aliases. Usually when it's that low, from my experience, that is usually a, no, that's not quite missing PM Sleep S4. PM Sleep is usually around like 15 to 20. Yeah, I don't disagree. Is Luce here? I don't know. If so, I'm sure I'm making an ass of myself. Pedro is a celebrity here. Alright, so let's go over and switch over onto our schematics here and just simply start with our power aliases and find out what is or isn't present. So that is going to be on what page? Page 100 or sheet 62. So first thing I'd like to look at for is PP bus G3 hot. That's just kind of the way that I operate. It's okay, we're just talking about you. Oh, thank you. Okay, let's see. Hopefully it was nothing bad. Okay, so let's go ahead and turn on our overhead camera. We're going to measure this what can I think right now? Fuse to check and see if we are getting PP bus 8.6. PP bus is in fact present. Dead CPU, you shut your mouth. You 0.03, 33 milliamps, not 300 milliamps. We are not going to talk about that yet. Okay, back onto our, that's right, I shifted things here in my OBS, so things are a little off. Let's check out to see if we have PP3V42 G3 hot. And that's usually around this part of the board. Present. Okay. Do we have real-time clock? Let's flip it over and check that out. Actually be a little bit easier if we look underneath the microscope for this one. PCH transplant, I really wait. Nope. You have green light PP3B43 present. Yes. You're not wrong. Sorry, I'm just kind of in the motions right now, just reading different things. But you're not wrong. It does make sense. Alrighty, here is our clock. PP3V42. I don't know, sometimes the light on this, well no, never mind. Never mind, I was about to say something stupid. Okay, 3.3 on clock. That is present. PP5ES5. That's measured right here next to U7400. You're doing great. Thanks, Pedro. $5 volts. Let's look at PP5ES4RS3. Oh, sorry. I didn't switch my screen over. So we're going to be looking around U7600 right now. That's about right here. Definitely a lot of dust in this area. Not present. Make sure that it's not shorted. Nope, perfectly fine. SPI not looking too hot. The SPI is mostly dusty. It looks like corrosion, but it's mostly dust. We'll actually just go ahead and give it a quick little wipe down. This is just a really dusty board. There's a couple of parts on here I thought were corrosion. Although, there was definitely something a little sticky right there that looked suspect. Oh, it was sticky because of the flux that's on our work mat. Yeah. Okay, so we're not going into an S4 state, and we are not shorted. So now let's check and see. PP3V3S5 should be present because we did get that on our clock. Yeah, just because we're already here, might as well. Okay, 3.3. How's you 5,000? I was just about to check that because if we're not going into an S4 state, feel like the 5.5. Oh wait, U5000. My bad. That is going to be the SMC. I'll take a look at that here in 1 second. Still really dusty in this area too. Don't really see any signs of corrosion. Okay, PP3B3S4 is not present. Cool. So just confirming the device is not going into an S4 state, which means we're probably missing PM Sleep S4L. JTAG is fine. I did look at that earlier, and it did look perfectly fine. Alright. Enjoyed watching your work. Thank you. But time to go solder my own stuff. Stay safe. Good luck. And thank you. You as well. And I hope it's not a PM Sleep S4 drama. That might be what's going on here. Okay. What I was doing real quick is just kind of measuring, make sure that nothing over here was grounded that could have been pulling something down. Only because we did have a lot of corrosion in this area. Didn't know if maybe it had time to oxidize and therefore actually damage a capacitor. So, nothing was wrong there. That was going to be my next step, Tim, was check and see if PM Sleep S4 was present. Solder balls, that is. Okay, so, since you already beat me to it, we're going to do PM Sleep, spell sleep properly, S4L. And let's see where you're located. Alright, let's see what we have right here. PM Sleep S4 is missing. Okay. So something seems to be going on here. Let's take a look at the solder balls underneath the SMC. And doesn't look like there's necessarily any corrosion over on that side. Look fine here. Okay. So normally whenever we have an issue with our PM Sleep S4L, it's going to be an issue either with the SPI, the SMC, the BIOS, or the clock. So I'm just kind of looking around the areas here. And just kind of cleaning this area up of dust so we can get a little bit better of a look. Alright, so let's find out if the SMC is even getting power. Humor me, check signals on U5110. SMC reset. Oh. 1 second. U5110. Let's check and see if SMC reset L is present coming from pin 5. It's going to be our bottom right part. Pardon me for a moment. The attachment I have for my power supply is just not long enough, so I'm actually switching up my cable right now. There we go. We got a little bit more breathing room. Okay, so let's switch back over. And the device is turning on. I think I have a bad cable. This was the cable I was using. This is a cable that I actually got from Paul's stream. And you can see that it's like a standard 12 volt DC connection, and the other side's going to be your MagSafe 2. So I just switched it back to an OEM adapter, and it's booting up. Yeah, looks like I was getting trolled by my own equipment here. Not using that one anymore. Back onto the original repair. This one's in for backlight repair. Did you say it's powering on? Yes. Triggered? Indeed. Alright, so if you use a power supply, I recommend using an OEM Apple charger, just slicing off the tip of it and plugging the outer metal shielding to ground and the inner insulated cable to power. That tend to resolve our issue here because our issue ultimately was our charger. You know, come to think of it, we actually had a client. Never mind. I just had an epiphany. We had a client drop off. It was actually that Thunderbolt that we just worked on earlier, where it wasn't turning on with our power supply. We were using that adapter. We were getting 0.33 milliamps. And so we thought it was an SMC PM Sleep S4L, but it actually turns out that the Thunderbolt was bad, given the amount of corrosion, preventing the device from turning on. So we were getting trolled here again with that cable, and it actually turned on with OEM. So I don't recommend using that adapter. I don't even think I have the packaging for it anymore, but it was something that we ended up trying from a stream that we saw before, and that's what I get for trying to try new tools. Back onto the backlight circuit repair. Let's replace that backlight. Okay, so we already have our area prepped. We just need to actually put some more flux over here. That was actually a little bit too much. Yes, exactly. The one that I just worked on earlier was trolling us, because I do recall a tech talking to us, or talking to me, saying that it was only pulling that much. Ultimately, it still needed a board repair, because when the client brought it in, it still wasn't turning on. But that entire time, it looked like we'd been trolled by our cable. Okay, so we need a replacement driver. Where are they? There they are. LP8550TLE. Looks like we've used a good bit of these, so we may have to end up ordering some more soon. Okay, so now that I have it out, just to give me a quick refresher, let's look at the orientation of this specific driver. Looks like pin 1 is going to be facing in our bottom left, so our dot is going to be facing in the bottom left as well. Change back over to our microscope camera, and let's get our driver lined up and prepped to be reflowed back into place. Reworked back into place. Reflow has such a negative connotation now. So whenever you're doing something like a BGA rework, you want to have your air output in just a lower, I guess, output, throughput. If you blow it too hard, the chip will go into your fume extractor and into the ether. You want to know how I know? So, if you use the Quick 861DW, I have mine set to 50 or 60 when doing BGA rework. But whenever I'm in the process of just moving the BGA off, I use more around 80 to 90 for the output. It does take a little bit longer, but it is going to prevent the chip from blowing away. It's thinking about it. I'm waiting for it to dance into place. Now let's turn up the output just a little bit more. And just kind of tapping it to wiggle it. So that's good. Now let's let that cool off for a minute. It's still a little bit too hot, so we'll let that continue to chill. This may be my last board repair for the stream, and if so, then I do have a couple more boards, but I like listening to music, don't have my Bluetooth headphones, and if I were to play anything, probably have a copyright takedown right now. No data, what's going on? Excellent connection. Okay, so yeah, I will probably do or put the board back together, make sure that the display actually comes on, and after that, just kind of turn on some jams and finish up the rest of the night taking care of that stuff. But let's see where we stand with this one. The sad thing with this repair is it's not the first time that I've had something equipment-wise troll me. And I find this to be a problem whenever, and now that I'm a board level technician, is whenever something comes in, not turning on, my mind goes into the most convoluted fixes. Oh, this device isn't turning on, probably because of this. We're going to have to look into the power rail. No, just the power button doesn't work. So that's where my wife kind of humbles me and makes me kind of take things back onto step one of diagnosing. Because it's very easy to get off track and go down rabbit holes looking at the wrong thing when, in this case, I just had a really bad non-OEM charger that was preventing this computer from turning on. So, never forget the essentials. Never skip your basics. Always start with step one. Don't perform brain surgery on someone when all they have is just a cough. Alright, so let's grab their fan. I'm going to make a video of me trying to replace the USB-C port on the A1708 and CD3215s. I bet you can't count more than 5 techs, and I have videos doing the repair. I know Lewis has done one. I bet you can't count more than 5 techs that have videos doing that repair. Oh, okay. Yeah. I understand what you mean now. Yeah, definitely Lewis has done a lot of repairs on that. I think Jessa did a video. Inwarp from Rossman Discord, also known as Alexi. He has done a video recently. I think Chris from Shiny Computers did one. I don't think I necessarily did a video titled CD3215 replacement, but I know I've done one in a live stream to do a repair. So you need to add your name onto the list. Get up there. Call it something clickbaity, like one trick Apple doesn't want you to know. You'll get so many clicks that way. One simple solution the Genius Bar hates. You can replace these non-replaceable parts. There you go. I like that. Okay. Let's check and see if we have backlight. Looks like the battery is dead, so we're gonna have to hook it up to our OEM working Apple MagSafe 2 charger. We have a fan spin, so let's option boot for this one. All right, we got a working backlight. Let's boot into an OS just to show that brightness control is working. All you need is a hot air station, a soldering station, a microscope, and your brain. Or if it was a BuzzFeed video, how to fix your MacBook in 9 easy steps. Step 1. Take it to Tim at Optimized Logic Repair. This screen almost looks like it has a peeling oleophobic layer, which is strange because MacBook Airs don't have that. It's just really oily. Oh, that's exactly what that is. It's just like oil, essentially. So this one's gonna need to be cleaned up too. Looks like it's almost like you know how things in your kitchen get oily from like cooking. At least I don't know if that's a southern thing here, but we get that with like fried foods. People just cooking fried food all the time. Oh, it looks like trackpad's not responding. But the keyboard's working. Shares the same cable. But yeah, how people deep fry and it just kind of leaves like an oily residue on like your microwave and things like that. That's kind of what's on this screen here. Is that this feels like this was in a kitchen. Even looks like there's oil. So this is probably a MacBook people use recipes for. Okay, so the SPI mode of the trackpad is working, but the USB mode wasn't. So if I had to guess, there actually is a tiny little kink right here. I probably don't have the cable in all the way, but the trackpad, or the keyboard at least, was working in USB mode. Looks like it's working SPI mode. And then last thing we want to do is just make sure that the actual brightness control is working. So we dim this all the way down, all the way up, and that is a successful backlight repair. We'd only been trolled because of this wrong cable that we had earlier. Really disappointed in that cable. It just added an extra 30 minutes into my time here that could have been spent elsewhere. But you live and you learn. We're going to move on from here. So that's a successful board repair. I'm going to go ahead and end the stream here just so I can actually play some music without getting flagged and having my video completely muted from YouTube. So that is a evening. Thank you so much for joining me tonight. Wish we could have made some more progress with the 16-inch. I'll see if we can try to do a little bit more of a stream when the BMU cable actually comes in from there. But until then, I plan to do a couple more of these now that I have a somewhat decent streaming computer till we can actually build the actual computer again. So yeah, without all ado, thank you again and have a wonderful evening.